welcome to those that are joining us right now. This is exciting. If people are there. Yeah, looks like people are there. So welcome to everybody who's joining us now for our, oh, there's a familiar face and a familiar background. Hello. Yes, welcome everybody. We'll start sharply at 7:30, but we wanted to welcome everybody ahead of time and thank you for joining us on our first Love Your Lake seminar series for 2023. We're pretty excited to be back and doing this, and one time we'll do this all in person. But I think everyone's probably grateful that we're not doing it in person due to all the snow that's out there. So hopefully you've got a cup of coffee, glass of wine, and sit back and are going to listen well for what's going to happen today and not worry about the snow too much. So we're getting people connected. I see, and everyone's either muting themselves, which is great. You're remembering for those that are joining. You can turn on your videos for now, but when we start this seminar, we'll ask everyone to turn off their video as well as mute themselves, just so that it's just better reception and you'll be able to hear it better. And our special guest speaker tonight will be spotlighted. So yeah, we're just going to wait for a couple more minutes for more to join. And that's great. Lots of people are joining us. And it's good to see faces. Let's see if there's another page. Hope everyone's not too overwhelmed by the snow and got your toboggan out. I know they had something on CBC about what is the best place to go tobogganing, so stay tuned. That'll be another seminar. Great. Welcome. See more joining. Beautiful. Jan will talk about, our LKO president will talk about the other seminars that we have that are coming this year. So that'll be exciting. There's other great seminars, and we're really thankful for this one. And don't forget to look at that LKO YouTube channel, because that YouTube channel's got lots of good videos from our past seminars. Well, gang, we've got maybe 60 more seconds. Maybe we can get started. What do you think? Is everyone gonna give me a thumbs up? All right, let's just get started. I think we're good. All right, good. And Scott McPhee, thank you so much for doing all that. Well, as I say, welcome and thank you everybody for joining us today as our first Love Your Lake Zoom seminar series for 2023. I'm going to introduce Wendy Hanson right now, and she's going to do our land acknowledgement.
As we gather here today, we respectfully acknowledge that we are situated on the traditional territories of the Anishinaabe Mississauga lands and the traditional territory covered by the Williams Treaties. Kashagawigamog, an Anishinaabe name meaning lake of long and winding waters, served for millennia as an important passageway and meeting area for First Nations peoples. We are grateful for the opportunity to live here, and we thank all of the generations of Indigenous people who have taken care of this land for thousands of years.
Thank you, Wendy. So as you might not remember, my name is Kirsten, and on behalf of the LKO board, which consists of Jan, Wendy, Tanya, Kathy, Scott, Marilyn, and Gary. They're waving, and their names are there on their LKO board member. We are really happy to bring these seminars to you, our LKO community. This evening's seminar topic, we have an amazing guest speaker tonight, Howard Simcover, and he'll be speaking on the wonders of the night sky. And if you've been with us before, after Howard speaks, there'll be an opportunity to ask questions. We ask that everyone uses the chat function. Scott and Jan and I will be monitoring that. We're not going to use we're just keeping everybody muted. But after the seminar is finished by Howard, then everyone can turn their videos on so we can see your beautiful faces, but we'll keep everybody muted and use the chat function for asking questions. Obviously, if Howard can't get to all your questions, we'll provide everybody that visits us with an email address that they can email to us, and we can get the questions that you have answered by Howard at a later time. As a reminder, the seminar is being recorded and is available to those who are not able to be here tonight, and they can watch it, as I said, on our LKO YouTube channel. So without further ado, let's get things started. I want to introduce Kathy Conlon, and she's going to introduce our guest speaker. Kathy.
Thanks, Kirsten. Howard is an electrical engineer by trade and an astronomer at night. He's been bringing the night sky alive to the public for over 50 years. Be ready to be fascinated and enthralled tonight, and have a paper and pencil or pen on hand, because Howard will be telling you some of the dates coming up when you can see some fantastic sights. Welcome, Howard.
Well, thank you. Thank you. It's really a pleasure to be here tonight. I appreciate the invitation. I've been involved with astronomy for virtually my whole life, since the age of 7. So I'm delighted to share some insights with all of you, wherever you're located, some insights about the wonders of the night sky. So I will share the screen. And here we go. So there's going to be 2 segments to tonight's presentation. And the first one, which will be perhaps 20% of the time I'll be speaking to you, that's going to be about light pollution and the night sky, a very important topic for the early 21st century. And the rest of the time, around 80%, we'll look at some wonders of the night sky that we can all see and enjoy. So let's start with the concept of light pollution. What is light pollution? Well, it's really the excessive and inappropriate use of artificial light. When we think of light, which is electromagnetic radiation, it's a form of energy. And light is wasted when it doesn't shine where it's intended to be. It may be obvious, but we need the right type of light directed in the right way at the right time, going in the right places. Now, as you see at the bottom of your screen, there's a typical view in a large North American city, and you can see the depth and breadth of the problem that we're facing with excessive use of light going in the wrong place, going upward into the sky. You can perhaps get an even better appreciation of the depth of the problem when you look down from the International Space Station. That is a real photograph taken from the ISS of northeastern North America. And you can see the dazzling amount of light that's emanating directly up into the sky, up to the space station and beyond, from the major cities on the ground. So why should we care about light pollution? Why is this important? There's a number of very important reasons, 3 of them. So light pollution has negative long-term impacts. And there's 3 areas that I will talk briefly about. There's our own health, there's the environment, and there's something that I call human heritage. So starting with our own health, we all have a circadian rhythm. And that is really defined as the physical, the mental, and the behavioral changes that follow the 24-hour cycle of light and darkness. Light pollution at night, in particular, disrupts our circadian rhythm. Now, you don't have to believe me. There's been a huge amount of medical research done over the past many years, and disruption of the circadian rhythm results in some very serious negative effects. A reduction in sleep quality, an increase in our stress levels, negative impacts on our immune system, which leaves us open to increased rates of very serious diseases, and that includes cancer and diabetes and other diseases as well. In terms of the environment, and I know many of you live in smaller communities by the lake and elsewhere, there are significant negative impacts on the natural world. For example, the nesting habits of animals and birds, the navigational capabilities of nocturnal creatures. Lights, such as in very large buildings in the downtown areas of our major cities, attract birds and insects, which leads to collisions and increased death rates and predation. Now, the CBC published an article last week, and there was extensive coverage, in fact, on CBC radio and television about an article that had been published in Nature just the previous week. Now, part of the CBC article had this picture. It's not a pretty picture, and this shows a huge number of birds that were killed when they struck illuminated buildings in Calgary, a negative effect of light pollution. Now, what about human heritage? Astronomy is one of the very oldest sciences. It goes back many, many, many thousands of years, and it's linked to the history of every human culture on the planet Earth. The night sky is used for many practical and esoteric purposes. You see some of them listed here: navigation, timekeeping, measuring the seasons, and spiritual and religious practices. So you see, light pollution weakens our connection to the past and it threatens these cultural traditions. And something that I would emphasize even more strongly is that it leads to a loss of what I call our sense of wonder at viewing a dark night sky that is filled with thousands of stars. So you don't have to take this from me. I'd like you to listen to Sarah Seeger. She is a Canadian astronomer who was born and grew up in Toronto. She now is a professor at MIT in Boston, where she studies the atmospheres of exoplanets, planets of other stars. She has received the Order of Canada, and she's currently the honorary president of the Royal Astronomical Society of Canada. Here is what she has to say.
As a child, I was always interested in astronomy. I saw the moon for the first time when I was a very small child, and later on at about age 10, I was on a camping trip with my father, and we went outside really late one night when it was dark, and I looked up at the sky and I had that, wow, I just couldn't believe there were so many stars. I had no idea that there were so many stars out there. And to this day, I always carried that with me.
She carries it with her many, many years later. So you see, this is exactly the wrong kind of outdoor lighting. This is located, this light standard, 75 meters away from where my wife and I live in downtown Ottawa. You can see when you look at the light fixture at the top of this column that the light can come out in all directions, including directly up into the sky. It's exactly the wrong type of lighting. So what we should be doing is choose lighting fixtures like this one. It's called a full cutoff fixture, which directs the light downward to the ground where the light is most useful. And many cities are in fact implementing full cutoff lighting. This particular fixture is 500 meters from where I live in a park. Right behind it is my wife's yoga center. And I'm happy to see more and more of this type of lighting appearing. We can also choose lighting of the right color. The color is very important. And that color is a softer yellow-orange color. The technical term is a lower color temperature. So when you buy LED lighting or compact fluorescent lighting at Home Depot or Canadian Tire or Rona or wherever, you can look for the color temperature being under 3000 degrees Kelvin. That is the right color. What we want to do is avoid blue or blue-white colors. This is scattered much more than the lower color temperature. It's scattered upwards into the sky. It causes glare and fatigue to the eye. And perhaps most importantly, it produces a reduction in the amount of melatonin that the body will create. I think you all know that melatonin is a hormone, and melatonin is required for long and restful sleep. So here's a graph. It shows the amount of melatonin produced in the blood, that's in picograms per milliliter, versus the hours of the night. So if a person is exposed to blue-white light, especially the light coming from iPads or computer screens or phones, because they emit a great deal of blue light, you will have less melatonin, you will have less restful sleep and negative impacts. So, you know, the advice that I try to follow is stop looking at my computer screen, stop looking at my phone after about 9 o'clock at night. And I've, you know, reaped some benefits from that, I think. So what can we do about light pollution? There are large-scale actions we can take, creating protected areas. Far-thinking municipalities, and there are examples of them, have implemented lighting bylaws and policies that will reduce light pollution and favor, for example, full cutoff fixtures in lighting. Examples of cities like that are Saanich, British Columbia, Mont-Mégantic in the province of Quebec, and Huntsville, Huntsville, Ontario, which is not all that far from Lake Kashaga-Wigamog. Now, as individuals, we can also take actions. I won't read all of them out here. There are some listed on the image, but these are things that we can do, whether we live in an apartment building, a condominium, or if we own a single-family dwelling, to reduce light pollution and prevent blue-white light from scattering up into the sky. We can also be ambassadors. We can speak with friends and family about light pollution. We can learn about it. We can educate ourselves, as I have done over the past few years. And maybe most importantly, we can show others what we ourselves are doing and take on that ambassador role. So that is segment number 1, light pollution and the night sky. And now we will go to segment number 2, and we'll consider some wonders of the sky that we can see and enjoy.
Ground control to Major Tom.
And thanks to David Bowie for that introduction to segment number 2. There are many, many things that we can see and enjoy in a dark night sky. And we don't need a telescope. We can use the human eye or a pair of binoculars, a simple pair of binoculars that can be purchased for less than perhaps $50 at Canadian Tire. So I'm going to show you many of these things in this segment. The first thing we need to do is imagine that we are going outside on a clear evening. The sun is sinking slowly into the southwest, and as the minutes go by, the sun sets, the sky begins to darken, and the starry sky reveals itself to us. If you're fortunate to have a dark night sky far away from the bright lights of the city, the stars are a truly awe-inspiring sight. The human eye can see up to 5,000 individual stars in a dark sky, going from one horizon all the way to the other. They shine like diamonds on black velvet. It's very rare that I myself get to see a sky like that, and I highly, highly recommend it. It connects us to the stars. It connects us to deep space and to the amazingly beautiful cosmos within which we find ourselves. So we're going to start our look at wonders of the night sky with something that you all know, and this is our own natural satellite, the moon, as it travels around the sky. This is a place where 12 humans have walked 50 years ago, but more humans are going back to the moon, and more humans will walk on the moon in perhaps just 2 or 3 more years. The moon travels around the sky in just under 30 days. And as you know, it goes through phases. It changes its appearance. The phases of the moon are due to the geometry that you see in this diagram. If we think of the sun as over at the right, the sunlight is coming in this direction. And I think it's pretty clear that exactly half of the moon and half of the Earth are lit up all the time. But depending on where the moon is, we will see different portions of that illuminated 50% of the moon. If the moon happens to be here, we on the Earth, when we look towards the moon, see just a very small portion of the illuminated hemisphere. So we see the moon as a crescent. And as the moon travels in its orbit, we see more and more of the illuminated portion till we see the full moon, the full illuminated portion, then less and less and less, a crescent, and then the moon disappears into the glare of the sun at new moon. I'm sure you've all noticed that when we have a very thin crescent moon, I took this picture at dawn in October, just before new moon, you can see the dark portion of the moon shining with a ghostly luminescence. I'm sure you've all noticed this. It's called Earthshine, and it was first explained by the famous scientist and artist Leonardo da Vinci around 500 years ago. Da Vinci realized that what we are seeing there is actually light reflected from the Earth. So sunlight strikes the Earth. The Earth has clouds and continents and oceans. In fact, about 37% of the light that hits the Earth reflects off. So that light, some of it, travels all the way to the moon, taking 2.5 seconds to get there at the speed of light, illuminates this portion of the moon, and about 12% of that light that hits the moon reflects all the way back to your eye. So you see that illuminated portion as what we call Earthshine. Now, it's a very interesting challenge to see a thin crescent moon, one that is just after new moon or just before new moon. It's a challenge that I personally enjoy, and I would recommend it to you. You may need binoculars. You will definitely need a very good horizon, because the very thin crescent moon is always very low down in the twilight. I took this picture from my condominium roof here in Ottawa in March of 2019, and that moon you are seeing in the picture was only about 18 hours after the new moon. Now, something else that we can enjoy, and I'm sure you have all seen this from time to time, is an eclipse of the moon. These can be extremely beautiful. They are visible to 1/2 of the Earth at the same time. The entire nighttime side of the Earth can see a lunar eclipse. So when you are watching one, you may be watching with 1 or 2 billion other people at the same time. enjoying the same celestial phenomenon. So what's really happening during a lunar eclipse, and this diagram is not to scale, that's very important for me to say that, the Earth is a solid object. The Earth is illuminated by the sun, and as a solid object, it casts a long shadow. The shadow of the Earth is 1.4 million kilometers long. It's like a long conical dunce cap. And at the distance of the moon, the shadow is big enough in cross-section for the moon to be able to fit entirely inside it. So that's what causes an eclipse of the moon, when the moon happens to pass through the Earth's shadow at full moon. This can only happen when the moon is opposite the sun at full moon. Now, the interesting thing here is that the inside of the Earth's shadow is not completely dark. The sunlight, as it is passing the Earth, passes through the Earth's atmosphere at the very edge of the Earth here, and the atmosphere refracts or bends red light or reddish light into the shadow. Therefore, during a lunar eclipse, the moon is very often an orange or red color. The media have seized on this in the past 5 or 10 years. They call it a blood moon. Astronomers don't refer to an eclipse that way, but it's still a very interesting and beautiful sight. Here are some pictures that I took of a lunar eclipse 2 years ago. It takes about an hour for the moon to gradually move into the shadow of the Earth. Notice that the edge of the Earth's shadow is a bit fuzzy, and the edge of the shadow is curved. The shadow is round. The Earth that we are standing on is essentially a sphere, and therefore a sphere, we know, is the only solid object that always produces a round shadow. The ancient Greek astronomers more than 2,000 years ago realized this, and they used lunar eclipses as one way of proving that the Earth was round. So I'm going to show you a little video, and this is made up of photos I took of a lunar eclipse in May of 2022. You'll see in the longer exposure photographs, the red color of the moon comes out and is very obvious. So here we go. It was a very beautiful eclipse, and I highly recommend that whenever you have the chance to see one, to go out. You don't need binoculars, you don't need a telescope. Just watching with the naked eye can, give you a great deal of pleasure, as it gives to me. So we've been very lucky in the past roughly 14 months. We actually have been able to see 3 lunar eclipses from most of Canada. When is the next one? Well, it's 2 years from now. And here is a date you can write down if you've got that pen and paper, March 14th, 2025, around 11 o'clock at night. We will all be treated to a total eclipse of the moon, and all we need is a clear sky. So we're going to leave the moon and we will go on to the planets of our solar system. People many thousands of years ago were aware of the planets. They could see them in the sky. Now watch carefully. Here's this ancient human looking up at a bright planet in the sky. Maybe it's the planet Mars. Watch it carefully. And you see over a period of days or weeks, it moves against the background of the stars. The stars do not move in relation to each other in reasonable periods of time. Over thousands of years, the stars will shift with respect to each other, but not in days, weeks, months, or decades. Now, early peoples were aware of 7 objects that wandered in the sky: the sun and the moon, and what we call today the 5 bright naked eye planets. These 7 wandering objects have given their names to the 7 days of the week. Obviously, the sun gave its name to Sunday, the moon gave its name to Monday, Saturn gave its name to Saturday. In French, we can much more easily see the connection between some of the other names. For example, Mars has given its name to Mardi, or Tuesday, Venus to Friday, or Vendredi in French. The planets are very bright. In fact, most of the time they are as bright or brighter than the brightest stars. Here I am standing on my condominium roof in August of 2018, and shining above me, very easily seen to the camera and the naked eye, was the bright red planet Mars. Here's a picture I took just 10 days ago. That is the brilliant planet Venus, easily visible in the evening sky after sunset. In fact, Venus is going to be very prominent in our evening skies for the next 5 months, and it will get brighter and higher in the sky as the time goes by. We can see Venus either in the evening sky or in the morning sky, but never in the middle of the night. And you might be curious as to why that would be. It all comes out of the geometry of their orbits. So there you see the sun, the orbit of the Earth, and the orbit of Venus. Venus is completely inside the orbit of the Earth. Now, if you think of the Earth as being 1 unit of distance from the sun on average, the distance of Venus is 0.7 units. So the ratio is 0.7 to 1. And that is the key to the visibility of Venus. So if Venus is where you see it in the diagram, if we stand on the Earth and we look towards the sun, and then we look towards Venus, you see we are looking to the right of the sun, to the right. And we see Venus to the right of the sun, which is to the west of the sun in the morning sky before sunrise. On the other hand, if Venus is over there at a different point in its orbit, if we look towards Venus, we see it to the left of the sun, and we see it in the east, to the east of the sun, and that is in the evening sky. Now, the angles down to the bottom, that's 47 degrees. And because of that ratio of 0.7 to 1, that leads directly to the fact that Venus can never appear more than 47 angular degrees away from the sun in the sky, which means you can see it in the evening or in the morning, but never in the middle of the night. So the summary is Venus can't be more than 47 degrees from the sun, and it will reach that point in early June of 2023, when it will be very obvious in the evening sky. It swings from one side of the sun to the other like a pendulum. You can never see Venus in the middle of the night, but only for a few hours before dawn or after sunset. So if we look at Venus in the sky, it moves away from the sun, taking months to do this, moves far over into the morning sky, reaches its maximum angular distance of 47 degrees, moves back toward the sun, passes the sun, goes into the evening sky, reaches its maximum distance of 47 degrees, and then comes back towards the sun. It's very obvious if we superimpose the orbit, and we can see exactly what's happening, swinging back and forth like a pendulum. So when you see Venus in the sky, think that it's the second planet from the sun. It's about the same size as the Earth. It's very different from our planet in most other respects. It's very, very hot with a very thick atmosphere, and the hottest place in the solar system where you can stand on solid ground, hotter even than the planet Mercury. And that's because it has a runaway greenhouse effect due to its carbon dioxide atmosphere. And it stands as a warning to us for what we need to do to control the emission of greenhouse gases and global climate change. But that is another story. We'll move on now to conjunctions of the moon and planets. A conjunction is when you have two objects come very close to each other in the sky. Technically, they have the same celestial longitude, but they are very close to each other in the sky. Now, the reason for this is again due to geometry. If you could look sideways at the solar system, you'd see that the moon and the orbits of all the planets are more or less in the same plane. If you had a tabletop and you put the solar system on the table, the orbits would fit more or less in the tabletop. Not exactly. Mercury's a bit of an anomaly because its orbit is tilted by 7 degrees, but still they would be fairly close to the plane of the tabletop. So this means that they can have very close approaches to each other in the sky. And let me give you some examples. So here's a picture I took on April 23rd, 1998. I was on a business trip to Chicago. I knew about this conjunction. I chose the hotel very carefully so that I would have a good eastern horizon. I set my alarm for 4 in the morning and went out before sunrise, and there was the moon and the bright planets Venus and Jupiter, a beautiful sight. Here's an amazing conjunction of Venus and Jupiter. I took this picture from my roof here in Ottawa. You can see Venus and Jupiter in February 1999. They are so close together in the sky, they look like a pair of headlights. And directly below them is the Parliament of Canada. Alas, I cannot get this view of Parliament from my roof anymore. Some apartment buildings have been built that block that particular view. Here's a conjunction of the moon and Venus, a very striking and beautiful sight in September of 2021. So what are some examples of conjunctions that you can observe and enjoy and photograph in the next few months? With your pen and paper, you may want to write this down, or you can look at the recording and get the information that way. So here we have an important date. February 22nd, 2023, 4 weeks from now, the moon will be very close to the planet Jupiter. You can see this in the evening sky 1 or 2 hours after sunset. It will be a very striking and very beautiful sight. A few days later, the moon will have moved from west to east against the stars. It will be a first quarter moon on February the 27th. It will be very close to the planet Mars, another very striking conjunction that you can see and photograph. And here is something not to be missed. 5 days later, look at this, March 2nd, 2023, 45 minutes after sunset, we will again have an extremely close conjunction of Venus and Jupiter low in the western sky. This will be spectacular, and you don't have to wait until March 2nd. We don't know if it will be clear that night. You can start watching a week before to watch Jupiter close in on Venus and then achieve this conjunction on March the 2nd. And 3 weeks later, a beautiful sight, March 24th, the moon above Venus, and down below the moon and Venus, Jupiter very close to the horizon. So several beautiful conjunctions that we can see all in the winter of 2023. So now we're going to go on to our next wonder of the night sky. I'm sure you've all seen meteors or falling stars, these flashes of light that we can see in the sky, or an entire meteor shower like the Perseids in August. Falling stars were made famous by this fellow. I remember when I was 7 years old, watching with my parents Perry Como on our little black and white TV, and he sang this song in 1957, the same year as the launch of Sputnik 1.
Catch a falling star and put it in your pocket, never let it fade away.
Yes, and you can even save it for a rainy day, as he went on to sing. But don't ask me to sing the song, please. These flashes of light in the sky, which we call meteors, these are caused by little particles from space, particles that might be the size of a grain of sand or a grain of rice traveling in their orbits around the sun. When one of these little particles enters the atmosphere of the Earth, it's traveling at very high speed, maybe 30, 40, 50 kilometers per second. So as it passes through the upper atmosphere, it undergoes friction. It begins to get very hot. It incandesces and then flashes its death, essentially, high in the atmosphere above our heads, and that is the flash of light that we see. If the particle is big enough to actually reach the surface of the Earth, we call it a meteorite. And as the limerick goes, a meteor is a flash of light made by a falling meteorite rushing through the air in flight and is usually seen at night. And gee, I hope this answer's right. You may want to write that down one day. So on certain occasions during the year, we can actually see a meteor shower. On any random night of the year, you might see 7 or 8 meteors per hour. But during a meteor shower, you might see 5 or 10 times that. It can be very beautiful and very impressive, especially in a very dark sky near the lake. So why do we have these meteor showers? The Earth, as it's traveling around the sun on its annual orbit, on particular days of the year, which are easily predicted, the Earth passes through a great swarm of these particles. The particles are traveling in a long elliptical orbit around the sun. They're distributed, in some cases, uniformly around that orbit. And the orbit is usually associated with that of a comet. So these particles are all bits of space debris that have been thrown off by the comet over many thousands of years. For example, the Perseid meteor shower in August is associated with comet Swift-Tuttle. The Orionid meteor shower, which occurs in October, is associated with comet Halley. So here's a list of the major meteor showers. You might even want to take a screenshot of that or look at it on the recording. But perhaps the most well-known meteor shower, because it occurs in warm weather when it's easier to observe, is the Perseid meteor shower, which happens on or about August the 12th of each year. And during the peak of the Perseids, you might see 50 or 60 of these meteors every hour. It's a wonderful thing to see if you go out very late at night. It's better after midnight. You will see more meteors after midnight and towards dawn than you will see before midnight. And the reason there is due to various elements of geometry that I won't go into tonight. So here we can see a video taken over many hours in the California desert of the Perseid meteor shower. Notice that over time, the sky appears to rotate as the Earth turns. The Perseids flash across the sky. Very beautiful. This year, on August the 12th, we will have a new moon. There will be no pesky bright moon to interfere with the Perseids. I strongly recommend, if it's clear, find a dark sky out at the lake or at some other location that you can travel away from the bright lights of the city and enjoy the Perseid meteor shower. And now, what about the stars? What about the starry sky itself? Early peoples were fascinated by the stars. They gazed up at them, they wondered about them, they divided them up into patterns and made up stories about these patterns of stars. Here we are seeing a pattern called Orion the Hunter. And this is a group of stars that early peoples thought was a hunter striding across the sky. Here is a very, very good photograph of Orion taken by my lifelong friend Ron Smith, who's on this Zoom call tonight. And notice here, this is the 3 stars of Orion's belt. From the belt hangs his sword, and notice the middle star of the sword looks fuzzy. It's something you can see beautifully in binoculars. Here's a picture I took of it from the Gatineau Park, north of Ottawa. This is a giant cloud of dust and gas. It's a star factory. It's a place where the gas is condensing inward and is producing new stars. This is a Hubble space photograph of the Great Nebula in Orion. This gas cloud is 1,300 light years away from the Earth. So how can you find these constellations in the sky and recognize them? When I was growing up, I used a book and I learned the sky from the book. Now you can use software that you can put on your iPad or your phone, but a very easy way to learn the constellations, which I recommend, is to start with something that we know and work outward from there, to start with the Big Dipper. I think we all know the Dipper. We can all pretty well recognize it. And early peoples thought of this as part of a larger constellation or group of stars that they called Ursa Major, or the Great Bear. We can use the Big Dipper to find the North Star. And many of you may already know how to do this. So there is Polaris, the North Star. We start with the Dipper. We take the last 2 stars in the bowl of the Dipper, project them outward about 5.5 times the distance between them, and it points very well to the North Star. There are many, many other of these constellation figures all across the sky. Here you see Cepheus and Cassiopeia and Andromeda and Perseus. And again, early peoples imagined that these figures represented men and women and objects, and they told stories about them. There's a whole story of Perseus and Andromeda. You can Google this and read the full story for yourself, but let me give you the 60-second version. King Cepheus and Queen Cassiopeia were the monarchs of Ethiopia. They had a daughter called Andromeda. Now, the queen was very vain and very self-centered. She thought that she was very beautiful, and she felt that her daughter Andromeda was extremely beautiful, more beautiful, she bragged, than the sea nymphs. Well, the sea nymphs heard this. They were very upset. And what they did was they complained to the god Poseidon, according to the story passed down to us by the Greeks. Poseidon was very angry and very insulted, And so what he did was to create and unleash the monster Cetus to ravage the coastline of Ethiopia. Well, the only solution apparently was to sacrifice Andromeda, tie her to a rock by the edge of the sea where she awaited the sea monster Cetus. But there's always a hero in the story, like in the old movies when the heroine was chained to the railway tracks, the hero turned up. In this case, it's Perseus riding the flying horse Pegasus. What he did very cleverly was he held up the head of Medusa, showed the head of Medusa to the monster, turned the monster to stone, and rescued Andromeda. They flew back to Greece, avoiding the airports, not losing their luggage. They married and lived happily ever after, having 8 children, and this was in a time before subsidized daycare and the child tax benefit.
And what became of me? Well, I was a mortal, and so, after many years, it was my fate to die. But as I was the wife of a hero and a demigod, Zeus decided to honour me. He turned me into a constellation called, naturally enough, Andromeda. My father and my mother, the winged horse Pegasus, and that beastly sea monster are all up here with me. Perseus is a bit further away. What's it like being a constellation? Well, life up here is pretty glitzy, as you can imagine. We have everything we need to sparkle and shine and look beautiful. We have wonderful views of the planets and the infinite majesty of space. But oh yes, I do miss the warmth of human blood in my veins and the embrace of my hero, Perseus.
And that is the story of Perseus and Andromeda. So how can you find the constellation Cassiopeia in the sky? It's very simple. You can use the Big Dipper, just as we use the Dipper to find Polaris. There is Polaris, and just beyond Polaris is Cassiopeia. Now, it looks more or less, as you see here, like a sideways W, depending on its orientation in the sky. Just use those 2 pointer stars in the Big Dipper, draw an arc past Polaris, and it points right to Queen Cassiopeia. Here's a picture of Cassiopeia that I took from the Gatineau Park. There's a lot of stars in there, but there is the sideways W. Once you get to recognize it, it's very obvious. Now, here is something interesting that you can do. Take these 2 stars in the sideways W, right here, extend them downward, and look, they point to a strange, fuzzy object. From the lake or in a dark location, you can even see this with the naked eye. In binoculars, look what you can see. This is called the double cluster. It's 2 clusters of hundreds of stars, 7,000 light years away from us. A very, very beautiful sight, the double cluster. You can also find the star cluster, the Pleiades, and these are often known as the 7 sisters. They're visible to the naked eye in the winter sky, and they present a very beautiful sight in binoculars. You can find them using the constellation of Orion. So here is Orion with the 3 stars of his belt and the sword with the great nebula. You take the upper left-hand star of Orion, draw a line through the head of Orion. It hits a red star called Aldebaran in Taurus the Bull, and then you extend that over to the Pleiades, or the 7 sisters. So that's how you can find the Pleiades in the winter sky. In binoculars, it's a very beautiful sight. Something like this. You might see as many as 15 or 20 stars in this very compact star cluster. Another wonder of the night sky is the Milky Way. Have you seen the Milky Way in a dark sky? I certainly hope that you have. These are pictures I took from the Gatineau Park north of Ottawa. The Milky Way presents itself as a hazy, ghostly band of light running all the way around the sky. It was Galileo 400 years ago who became the first person to look at the Milky Way through a telescope, and he realized it was made up of thousands upon thousands of stars. In fact, we know that the Milky Way is actually a galaxy. It contains 200 billion stars. If we could see it from the outside, looking down from above, or see it edgewise, it probably would look something like this, with spiral arms emanating out from the center. And our sun is a very ordinary yellow star of the 200 billion stars of the Milky Way. We are nowhere near the center of the Milky Way, but about 2/3 of the way out from the center towards the edge. We are 30,000 light years from the middle of the Milky Way. The entire galaxy is rotating very slowly, taking over 200 million years to make one spin. Since the extinction of the dinosaurs 66 million years ago, the Milky Way has made only 1/4 of a turn. So when you look at the Milky Way over a lake in a dark sky, recognize that you're looking at the combined light of billions of distant stars. We believe that many of those stars, probably the vast majority of them, have planetary systems. And it may well be that there are other intelligent civilizations on those planets of other stars in some cases, and perhaps they too are gazing out at the Milky Way at night, just as we are from here on the Earth. Now, as we come close to the end, we're going to finish with one other wonder of the night sky, and this is the Aurora Borealis, or the Northern Lights. Have you been fortunate enough to see a good display of the Northern Lights? I hope you have. You have to be lucky. They're not all that common from our latitude in southern Canada. I'm in Ottawa at about 45.5 degrees north latitude. The aurora are much more common the further north you go. Calgary, Edmonton, Yellowknife, Iqaluit. You can see them much more often from there. And the reason will be clear in a moment. Usually they're a kind of blue or greenish color. Occasionally we can get a red or even purple aurora. Those are relatively rare. This picture was taken from the International Space Station, looking down on the Aurora Borealis. It's an amazing picture. So you can see that the aurora are actually happening in the upper atmosphere of the Earth. So what is causing these shimmering displays of ghostly light? Well, it's activity on the sun. When there is major activity such as a flare or other emanation from the sun, solar particles, electrically charged particles that make up what we call the solar wind, travel outwards from the sun. They will take 2 or 3 days perhaps to reach the Earth. They are deflected by the magnetic field of our planet and directed down towards the north polar regions and the south polar regions, causing displays of the Aurora Borealis. The molecules or atoms of gases in the upper atmosphere, they're absorbing the energy from these particles and then emitting the energy as visible light. Oxygen gives us the green and yellow color. Nitrogen gives us red or blue or purple. So wrapping up, there are many actions that we can take as individuals to reduce light pollution, as I had mentioned. And there are many, many phenomena that we can enjoy in the night sky, just with our eyes or with binoculars. So for example, we can watch the moon as it travels on its orbit around the Earth. We can locate and enjoy the bright planets and their conjunctions with each other and with the moon. We can enjoy the stars on a dark and clear night. We can learn about the constellations and read about their stories. We can find specific deep sky objects like the Orion Nebula. We can see the Milky Way, our home galaxy, watch a meteor shower. We can experience eclipses of the moon and the shimmering beauty of the aurora. So we're going to close with this short video, and I give all the credit to Yasushi Tenikado, who took these photographs from Whitehorse in the Yukon. It's been a real pleasure for me to spend this time with you tonight. I'm certainly open to any questions, and I will stop the share and turn this back over to your moderator. Thank you very much.
Oh, thank you so much, Howard. That was a real treat, I have to say. Really enjoyed that presentation. So thank you. And I challenge or encourage people to, on those dates that Howard provided us with, to share photos of any sightings of Venus and Mars and the moon, or Venus and Jupiter rather, to share, that we can share through our social media, because we would welcome that sort of challenge or encouragement to take pictures to share. That would be quite fun to do. At this point in time of our presentation, we welcome questions. And that, just as we've mentioned before, just put them through the chat function, and we'll get as many questions answered as possible from Howard. There's one that's come through. Is there a website, Howard, to find all the conjunctions for each month?
It's a great question. Actually, there's not that I'm aware of, but what you can do is use what's called Stellarium. Now, it was on one of my slides. It's available on the web. I think it's stellarium.org.
Yeah, I think it's stellarium-web.org. I wrote it down.
Right, -web.org. If you go there, that's what I use to produce the simulations of those conjunctions that I showed, in the images. All you have to do is cycle through the dates of the month and take a look at what develops, follow the moon, follow the planets, and you will see these upcoming conjunctions. So that's what I suggest.
Okay, perfect. So that was stellarium-web.org, stellarium-web.org as a site to look at. Thank you for that. Before we get to this, and Gary, I would love to be able to share his screen if possible, because he is an example of light pollution, I think, over the lake, Keshagwigmog, and he wouldn't want to share that. So while we're waiting for that, there's another sort of a comment, and congratulations, well done, Howard. You recreated a great planetarium at the Griffith Observatory, Wonders of the sky. So someone had congratulated you on that. Another person is asking, could you speak of the relatively recent phenomena of the satellite trains of low orbiting satellites? We had mentioned a bit of that before we started this workshop or this seminar.
Yeah, thank you for that question. This is a terrible problem in that thousands of these satellites are being launched essentially for communications purposes, to provide internet to remote areas of the Earth. And I sympathize with that. I understand the objective, but these thousands of satellites are cluttering the night sky. They are reflecting light back down to the Earth. I was mentioning to, I guess, some of the board members before we started tonight that when I take a 30-second exposure in a dark sky of some portion of the sky, I seem to have a 40 or 50% chance of having a satellite pass across the field of view. So it's a terrible problem. We need international regulations. They are sadly lacking at the moment. And I would love to see fewer and fewer of these satellites instead of more and more of them. I am as concerned as you are, the person asking the question.
Yes, yes. I think as we mentioned before this started, it's quite upsetting on many levels. Is there any other questions? I don't have any other questions in our chat function. If there are any questions, please feel free to type them in there. Scott McPhee, are you able to ask Gary or create Gary to be a co-host so he could just share his screen? I think he's wanting to share the light pollution photo, I think, Gary?
That's correct.
Okay. Is that possible, Scott McPhee?
It says the host has disallowed screen sharing, so I
Yes.
can't show.
No.
Does that work, Gary?
Gary or Scott just made you a co-host, Gary. So if you wanted to share, I think he's just sharing a picture.
There it is. Tell me if you see it, and I'll make a few comments.
There we go.
Can you
Looks
see
good.
it? I got a few things to say about it. First of all, every year, more and more people seem to love patio lights. Even later in the evening, they leave them on all night because they're LEDs and they don't cost very much. And the other thing I would like Howard's comment on, you can see in the lower distance there, there's always a glow over the horizon. And Bonnie View is, I don't know if you've seen my cursor, Bonnie View are the lights in the left. And in the distance, I looked on a map and it looks like the only thing I can see is Minden, and that's 18 kilometers away, the closest town in that direction. Can light pollution still affect you that far away is my question.
Yeah, the answer is clearly it can. You may want to go over and have a look at that town and see what kind of light fixtures they are using in the town itself. And it may well be that they've got a lot of light that is streaming directly up into the sky. So you're seeing it from 18 kilometers away, clearly.
So I just wanted to show people that still there are a lot of people that put a lot of lights. And let me just show you, when I work with this photo, and try to boost the Milky Way, and that's I think that's an airplane or a satellite that's streaked there. You can see how it sort of eliminates the whole horizon level, so you really can't get a very good shot. I do have two more to show. If I try later at night and higher up and try to avoid the horizon, this is what you would see pretty much with the naked eye. It's a little bit of haze, but you can get an image like this out of it if you take multiple shots and you sort of average them out. There's software that will do it and then boost your colors. So you can still do it from Lake Cashagawigamog, but it ain't easy with all the light pollution.
Yeah, you've done very well there with the Milky Way, and that gap between the two portions of the Milky Way, that is actually a long, area of dark dust and gas in space. So there's actually stars in the Milky Way beyond it, but the dust and gas is blocking our view, which is why we see those two branches of the Milky Way in the sky. It's a very good photograph. Good for you.
Oh, thank you. So the problem though is to get people educated. I think, as you mentioned, there was a good article in our local newspaper, I think it was last fall, about light pollution. But I'm not sure that people that leave their lights on all night or do this, I'm not sure that they are aware of this problem around our lake, and not sure what we can do about it.
Well, I think we can. We've done a bit of education through our e-blast that we send out to our LKO members, or more than our LKO members that are no longer members, but they're still getting they're still benefiting from the wonders of our e-blast. So that's marvelous. And so we do that kind of education. And I mean, we're doing our part. And by having this seminar, I think we're trying to educate people. And there's been a fair amount of people that have joined tonight, so that we can say that to us is a success for sure on that. So, but I think you're right, Gary, more needs to get done. And thank you for sharing those photos.
The people who are here tonight are probably the ones that
You're talking to the choir.
are very simple.
Yeah.
A very polished presentation, Howard. Thank you.
Yeah.
You're very kind, Gary. Thank you. Are there any other questions for me? Anything that I can help anyone with? I'd be delighted to do so.
At the moment, I mean, if the people are putting into the chat, there isn't any more at the moment.
Nothing at my end.
Not your end either. Okay.
Okay.
Because I think you covered everything so beautifully, Gary. I mean, not Gary, Howard, rather. You covered
You're welcome.
so beautifully that people are left. Wow. I mean, it was really comprehensive and interesting, and just a great presentation, really informative. So I think if there's no other questions, and I think I'm going to pass it over to Jan Giroux to say thank you for being our guest speaker tonight.
Thank you.
Yes, here's your wonderful virtual thank you, Howard. But we really, we really enjoyed the presentation tonight. And thank you for the time that you took to put it together. And I've certainly learned a great deal. It was really a wonderful presentation that you made. And this concludes our seminar for tonight. Just a reminder to people that we have 3 more seminars coming up. One on March the 1st. It's a Wednesday again at 7:30. The topic has not been firmed up yet. We're hoping to have something on boating. On March the 29th, we have Dr. Chris Hauser, who's going to speak on the science of vessel-generated waves. And on April 26th, Rob Davis is going to be speaking specifically about septic issues and the new septic inspection program that's coming to our lake this coming spring and summer. So thanks to everyone for coming to the seminar tonight, and especially thank you to you, Howard, for your wonderful presentation.
Yes, thank you everyone. Give him a round of applause virtually if you can do it or whatever. And if you do have questions that you think of afterwards that you didn't get a chance to talk about, feel free to email social@lko.ca and we'll send your question to Howard and make that make him answer the questions for us. No, send the question to him so that he can answer them. But thank you. That's great. It was wonderful. So Thank you for joining us on Point 8.
Thank you again. It was really a pleasure. I send you all my best wishes and clear, dark skies.
Yes.
Hey, Howard, speaking of that, are you going to look for the comet that's out?
I am going to look for the comet. It's quite faint. This is not something that will light up a newspaper that you can read. It takes binoculars and a dark sky. So I haven't seen it yet because I'm under 100% clouds and snow.
Snow, yeah.
But yes, I do plan to see it. Thank you.
It's about 5.4 magnitude now, I think. We're going to try to look at it here. I'm down in Toronto right now, but in a city, I don't know how we're going to do.
Good luck. look, if you do capture it, Gary, send us the picture and we'll spotlight
It
it.
won't be as good as my Milky Way shots from Lake Cashel.
Well, you send us those ones too. We'd be happy to post them and credit you for the wonderful photos, because the more people learn about this kind of thing, the more we'll have a happier
Dark
lake.
skies.
Yes. So this concludes our thing. So thank you so much. We've had a great time, and we'll look forward to seeing everybody again soon. And thank you again, Howard.
Thank you, Howard.
Thank you, Howard.
Thank you.
Thank you. Good night, all.
Thanks
Thank
for
you.
night.
arranging it.
Good night.